Forces, Part 1. In this course, we're going to define force, explain the two categories of forces, and learn about the different types of forces. A force is a push, pull, or twist on an object with mass that causes it to change its velocity. Forces can change an object's speed, direction, and shape. Force is measured in SI units of newtons. A spring balance or a force meter is used to measure force. Forces are represented as arrows. The direction of the arrow gives the direction of the force. The length of the arrow represents the size of the force. Force has both size, magnitude, and direction, hence it is a vector quantity. In this video, a dung beetle is using a force of 4 newtons to push dung up a hill in a northwest direction. There are two categories of forces. First, we have the contact forces, and then we have non-contact forces. When objects need to touch for the force to exist, then these forces are categorized as contact forces. Examples of contact forces are friction, upthrust, push, pull, twist, and tension. When objects are not in direct contact with each other, but forces still exist between them, they are categorized as non-contact forces. Examples of non-contact forces are gravitational, magnetic, electrical, and nuclear. Objects are stationary when all forces acting on them are equal, but are in opposite directions to each other. The forces moving in the northern and the southern directions are parallel to each other. They're the same size, and therefore they'll be subtracted from each other to give a resultant force of 0. The forces moving in the western and eastern directions are parallel to each other. They're the same size, and hence they would be subtracted from each other to give 0 newtons. An object moves if there's an unbalanced force acting on it. On a plane, there are 4 forces acting upon it. There's lift, weight, drag, and thrust. Lift and weight are parallel to each other, acting in opposite directions. Thrust and drag are parallel to each other, acting in opposite directions. If there's more lift than weight, the plane will rise, and if there's more thrust than drag, the plane will go forward. Forces in the same direction that are parallel are added. If there are 2 forces, 5 newtons and 3 newtons acting on the cell phone in the same direction, what is the resultant force? Correct. The resultant force will be 8. Forces moving in parallel and opposite directions are subtracted. If a force of 5 newtons is moving to the right and a force of 3 newtons is moving to the left, then what is the resultant force? Correct. The resultant force will be 2. Comprehension. What is a force? A string is tied to an apple and hung from a fixed point. What force is being transmitted through the string? List one contact force and one non-contact force. You may pause the video to answer these questions. Force is a push, pull, or twist on an object with mass that causes it to change its velocity. The force that is being transmitted through the string is tension. Contact forces may be push, pull, twist, tension, or friction, while non-contact forces may be gravity, nuclear, electrical, or magnetic. What is the SI unit of force? Name the instrument used to measure force. What shape is used to represent force? You may pause the video to answer these questions. The SI unit of force is the Newton. The instrument used to measure force is called a spring balance or force meter. The shape that is used to represent force is an arrow. Comprehension. The force of the wind pushing a tennis ball in an eastern direction is 5 newtons, but the ball is experiencing friction of 2 newtons in the opposite direction. What is the resultant force of the system? You may pause this video to solve the question. If you got 3 newtons to the east, then you are correct because two forces are parallel to each other, however, they're moving in opposite directions to each other. Hence, there'll be a subtraction of the smaller number from the larger number. Part 2. In this section of forces, we are going to explore friction, gravity, weight, and mass. Friction is a type of force that opposes motion. It occurs when two surfaces move over each other. Friction increases if the surfaces are rough and if they're closer together. Here we have an example of friction. Heat energy is produced as a result of friction. There are many benefits of friction, like walking, writing, erasing, washing, and driving. However, friction can make movement difficult. For instance, friction makes it difficult to push a box across a rough floor. It even makes it difficult to walk through deep snow, sand, or even water. Friction can also waste heat energy. It causes pads to heat up if they are not lubricated properly, and it also causes wear and tear, for example, the soles of your shoes and a pencil eraser. To reduce friction, ball bearings or wheels can be used, grease and lubricants can be used as well, fluids that are not as thick may be used, cars and planes can be made more streamlined, smoother surfaces may be employed, and using air cushions or hovercrafts to glide across terrain can be used. Gravity is the force that a body exerts upon another body. On the Earth, the gravity or gravitational field strength, G, is about 10 newtons per kilograms or 10 meters per second squared. Every object or body in the universe has gravity or gravitational field strength. Gravity is a force of attraction between all objects. It is a non-contact force. Gravity increases when mass increases. The gravity on Earth is about 9.6 0.81 newtons per kilograms. Earth has a mass of 6 septillion kilograms. The gravity on Jupiter is greater. It is 24.79 newtons per kilograms. It has a mass of 2 octillion kilograms. The Sun's gravity is 247 newtons per kilograms, and it has a mass of 2 nonillion kilograms. Since the Earth is not a perfect sphere, the weight of a body varies over the Earth's surface. The nearer a body is to the center of the Earth, the more the Earth attracts it. This is why the pull of gravity is greater at the north and south poles than at the equator. Weight is a force which acts on an object because of the gravitational attraction between the object and whatever it is on, in this case, Earth. The SI unit of weight is the Newton. The weight of an object depends on the mass of the object and the gravitational field strength acting on it. While the gravitational field strength of a body depends on its mass and size, it is also dependent on the distance between the centers of the two objects. To determine the weight of an object on Earth, it can be done by multiplying the object's mass by the gravitational field strength of the Earth's. For instance, the jelly nut has a mass of 1 kilogram. The gravitational field strength of Earth is approximately 10 newtons per kilogram. Therefore, the jelly nut's weight would be 1 kilogram multiplied by 10 newtons per kilogram to give us 10 newtons. The mass of a body is the same wherever it is and does not depend on the gravitational field strength of another body like weight does. In the picture, we have the mass of the astronaut being the same on Earth as it is on the Moon, which is 60 kilograms. The gravity on Earth is approximately 10 newtons per kilogram, while the gravity on the Moon is approximately 1.6 newtons per kilogram. What then would be the weight of the astronaut on the Earth, and what will be the weight of the astronaut on the Moon? Correct. If you got the weight of the astronaut on Earth to be 600 newtons, bravo. If you got the weight of the astronaut on the Moon to be 96 newtons, excellent. This tells us that we are heavier on Earth as opposed to on the Moon, because there's less gravity on the Moon than there is on Earth. Fun facts about the Moon. 1 day on the Moon is equivalent to 1 month on Earth. Gravity on the Moon is 1/6 of that on the Earth, which is 1.6 newtons per kilogram. Meteorites hit the Moon every day. The Moon was formed billions of years ago when a giant asteroid struck the Earth and sent debris into Earth's orbit. It is Earth's natural satellite. The Moon is slowly drifting away from Earth. There is no air on the Moon. Components of air are made up of biological life forms. Hence, there is no life on the Moon. Temperatures on the Moon can dip down to negative 153 degrees Celsius during the night and rise to 107 degrees Celsius in the daytime. Almost all the minerals on Earth can be found on the Moon. The SI unit of mass is the kilogram. Mass is measured with a triple beam balance or top pan balance. When using a triple beam balance, an unknown mass is placed on the pan and is balanced against known masses on the lever. A top pan balance is a digital instrument, and the accuracy of a reading is determined by the scale setting used based on the sensitivity of the balance. Comprehension. What type of force is friction, gravity, and magnetism? What is friction? List 2 benefits of friction. You may pause the video to answer these questions. Friction is a contact force, while gravity and magnetism are both non-contact forces. Friction is a type of force that opposes motion. Some benefits of friction include writing, walking, erasing, washing, and driving. Comprehension. List some disadvantages of friction. List 2 ways in which friction can be reduced. What is gravity? You may pause the video to answer these questions. Answers. Friction can impede motion or progress. For example, walking through water, sand, or snow. It also causes wear and tear and wastes heat energy. Lubricating machine pads, using smoother surfaces and using ball bearings, and designing more aerodynamic or streamlined cars can reduce friction. And gravity is the force that a body exerts on another body. Comprehension. What is the value of gravity on Earth? What units are used to express gravity? Define weight and list its SI unit. Juniper has a mass of 50 kilograms. What would be her mass on the moon if the gravitational field strength is 1.6 newtons per kilograms there? You may pause the video to answer these questions. Answers. The value of gravity on Earth is approximately 10, but to be more precise, 9.8. The units of gravity are meters per second squared or newtons per kilograms. Weight is a force which acts on an object because of the gravitational attraction between the object and whatever it is on. Its SI unit is Newton. Juniper's mass will be 50 kilograms since mass does not change. Comprehension. True or false? The moon was once a part of the earth. True or false? Gold and silver can be found on the moon. What is the SI unit of mass? You may pause the video to answer these questions. Answers. True. The moon was once a part of the earth. It is debris from when the earth was hit by a giant asteroid billions of years ago. True. Gold and silver, which are minerals by the way, can be found on the moon since it was once a part of earth. And the SI unit of mass is the kilogram. Comprehension. True or false? There is air on the moon. What instruments can be used to measure mass? You may pause the video to answer these questions. False. There is no air on the earth. A triple beam balance or top pan balance can be used to measure mass. Part 3. In this section, we will be exploring machines. Work is done when a force moves. Work is equal to force times distance. If there is no movement, no work is being done. For example, holding an object. Work is also done when there is a change in energy. The SI unit of work is the joule. A machine is a device used to make work easier. A force being applied to a machine is called the effort, and the object being moved is called the resistance or the load. There are different types of machine. You have gears, which are found in clocks. You have the inclined plane. Examples of the inclined plane include a ladder, ramp, or steps. Then there's the lever, which can be represented by a seesaw, a broom, scissors, shovel, tweezer. Then there's the screw. A car jack is an example of a screw. Also, the lids of jars. A pulley is a different type of machine which can be found in cranes. A wedge is also a machine which can be used as a doorstop. And then we have the wheel and axle machine, which can be seen in the form of a rolling pin or a steering wheel. A complex or compound machine has two or more simple machines working together. Examples of these are bicycles, cars, and cranes. A lever is a simple device or machine which makes work easier. In a system that involves a lever, load, and a pivot, as shown in the picture, when a force is applied, known as the effort, levers turn about a pivot when doing work to move the resisting force or load. This is referred to as the turning effect. Some examples of levers are scissors, bottle openers, crowbars, pliers, seesaws, tweezers, wheelbarrows, spanners, and a hammer. Levers can be classified into three classes: first, second, and third. In first class levers, the load comes before the fulcrum followed by the effort. In second class levers, the fulcrum comes before the load followed by the effort. And in third class levers, the fulcrum comes before the effort followed by the load. Here are some examples of first class levers, such as the claw and the pliers. Examples of second class levers are the wheelbarrow and the nutcracker. And examples of third class levers would be the human hand holding a load or sugar tongs. When a force acts on an object, it may cause a turning effect known as the moment of the force. The turning effect depends on A, the size of the force applied, and B, the distance the force is away from the pivot. The turning moment M can be calculated using the equation below. Turning moment is equal to force times distance. The unit of moment of a force is the Newton meter. It is not equivalent to a joule because the distance measured is perpendicular to the force and not in the direction of the force. If a pivot or fulcrum is placed directly at the center of a lever, it will balance or be in equilibrium. The further away from the center the pivot or fulcrum moves along a lever, the more likely it is to turn. When an object is in equilibrium, it is not accelerating or rotating. The two equilibrium conditions are such that there is no resultant force acting on the object, and 2, the clockwise moment is equal to the anti-clockwise moment, and this second point is referred to as the principle of moments. Force A and force B will cause the lever to turn in a clockwise direction. Applying force C and force D will cause the lever to turn in an anti-clockwise direction. If a force of 20 newtons is 2 meters from the pivot, what is the moment of the system below? It will be force times the distance, the force being 20 newtons, times the 2 meters, which is the distance away from the pivot, to give you 40 Newton meters. That's the moment of the force of this system. If a force of 50 newtons is 1 meter away from the pivot, what is the turning moment of the system below? Awesome! Yes, definitely the turning moment would be 50 Newton meters. If a force of 20 newtons is 2 meters away from the pivot, what is the moment of the system below? Awesome! 40 Newton meters. Correct. If the system is in equilibrium, then what is the value of force X? First, we have to determine which force is clockwise and which force is anti-clockwise, and then we equate them. If you look at your forces on the left, if you split this system in half, the forces on the left will cause the system to turn anti-clockwise. If you move over to the right now, on the right of the pivot, you will see that this force will cause the system to move in a clockwise motion. So if we work out our clockwise moments, which we have everything for, we'll get 20 Newton meters. To work out the force for the anti-clockwise moment, we need to note that the sum of all anti-clockwise moments will be equal to the sum of all clockwise moments. Therefore, whatever multiplied by 5 should give us 20 Newton meters. We know 5 times what gives us 20. Yay! 4 Newton meters. Comprehension. When is work done? What is the SI unit of work? What is a machine? Name the different types of machines. You may pause this video to answer the questions. Work is done when a force moves. Work is also done when there is a change in energy. Joule is the SI unit of work. A machine is a device used to make work easier. Gears, inclined planes, wedges, screws, wheel and axles, and levers are different types of machines. Comprehension. Give some examples of complex or compound machines. What is a lever? And list some examples of levers. You may pause the video to answer these questions. Cranes, cars, bikes, and washing machines are all examples of complex or compound machines because they have 2 or more simple machines working together. A lever is a simple device or machine that makes work easier. Scissors, wheelbarrow, tweezers, and a hammer are examples of levers. Comprehension. How many classes of levers are there? What type of lever is a nutcracker and a pliers? You may pause the video to answer these questions. There are 3 classes of levers: first, second, and third class levers. A nutcracker is a second class lever, while a pliers is a first class lever. Comprehension. What is a turning effect? What is a moment? You may pause this video to answer these questions. The turning effect occurs when a force or effort is applied to a lever and it turns about a pivot when doing work to move a load. A turning effect is also referred to as the moment of the force which causes a lever to turn. Comprehension. What does the turning effect depend on? What is the formula used to determine the turning moment of a system? And what is the unit of moment? The turning effect depends on the size of the force and how far away the force is from the pivot. The formula for the moment of a system is equal to force times distance. The unit of moment is the Newton meter. Comprehension. What is the principle of moments? You may pause this video to answer this question. The sum of all clockwise moments is equal to the sum of all anti-clockwise moments for a system that is in equilibrium. Comprehension. The turning moment for the system below is, you may pause the video to answer this question. Correct, 150 Newton meters. Very good. Comprehension. If the system is balanced, then A is equal to, you may pause this video to answer the question. The sum of clockwise moments is equal to the sum of anti-clockwise moments. If the clockwise moments is equal to force times distance, then we have here 8 newtons times 3 newtons to give us 24 Newton meters. Therefore, the anti-clockwise moments are supposed to be equal to 24 Newton meters. So, if you have 6 newtons multiplied by an unknown distance to get 24, we need to know 6 times what gives us 24. Aha! We find that it is 4 meters. Remember, before we start any question, we always determine our clockwise moments as well as our anti-clockwise moments. And that's a wrap, folks. See you around for the next lesson. Bye!